Got it.
So in our first exploration in lens 1, you can obviously see that the lens creates a more clear and larger image. However, this becomes blurry the more you retract from the lens. In lens 2, you're able to see that the lens creates a more larger and clearer image the more you retract the lens from the mirror. And however, the closer you bring the mirror, the more of the actual size it actually appears. In lens 3, the lens creates a smaller image the more you retract the image from the beetle. However, when the mirror comes closer to the mirror, it becomes the actual size. When we skip forward to the coin on exploration 2, the more water that was poured in the cup, the more I could see the image of the penny, and the coin did not move physically. I was able to see an image because of the fact that the water has a reflection. In exploration 2, when we did it with a pencil, you could always see the illusion between the pencil and the water. The pencil becomes more larger and out of place and appears as an illusion because the water has its own reflection. So in this experiment, we're going to go ahead and pour the water into the cup. As you can see, you cannot see the penny right now. But if I go over here, you can clearly see it. At this angle, I cannot. Go ahead, pour the water. And now because of the water's reflection, you can easily see the penny. As you can see, it didn't move the camera at all. This is just an image reflection.
Experiment, we're going to be showing the reflection from the water and see how it kind of absorbs and moves the pencil inside the water.
Alright, and as you can clearly see, the visual differences between the two. The pencil looks like it's been cut. It's much larger on the water scale versus in real life, the virtual versus the real image, and that's the differences between the two.
For exploration 3, set up with cardboard only, the light emits rays on the slatted plates because of the certain angle which it is placed at. This is because of the angle of reflection and the holes in the plate that gives us this image. For exploration 3, lens 1, the lens shows improvement within the light rays displayed. The rays appear larger and move much clearer than before. Lens 1 is successful in emitting reflections. For exploration lens 2, the reflection from the slotted plates move the lights in a downward motion. The light establishes into this picture. For our exploration 3, lens 3, the reflection from the slotted plates move the lights in a separation. The light establishes into this picture.
Exploration 4, lens 1. This seems to be a reflection of the card inverted on the cardboard. This is obviously as the inverted image is very well displayed with the same size as well. The second lens showed a upright angle of the image with image size increased. It seems that the second lens making it obviously different compared to the first one. Lens 3. The image was much harder to find as it appeared to be a virtual image. The candle had to be adjusted several times in order to obtain a decent picture.
Exploration 5. In order to see the clear image, we have to adjust the lens back and forth. Adjusting the screen give us a better image to see the candlelight through the lens. Just like moving the lens up and down to see clearly, so the image in the distance adjusted. Lens 1 is double than that of lens 2. The distance of the image from lens 1 are almost double or triple that of the distance from lens 2.
And so in exploration 6, when you move the candle in the right spot in correlation with the lens, you can see a clear image of the actual candle light on the screen. But if you move the screen towards the lens, you do not see an image of the candle. But when you move it away, you begin to see it clearly. If you move the screen, you had to move the candle to the left or to the right to see a clear image. Well, we're at 20 centimeters with lens 1, we're at 38. And the distance of the object when we were using lens 2 was 10 centimeters, and we got 33 centimeters. So it looks like it decreased on the second lens for most part. The image size appeared to be smaller most of the time, and as well as the image position seemed to be inversely the same, both for either right side up or upside down. Both images were displayed clearly. The image brightness was just about more or less and equal on both sides, a little bit more, a little bit less, depending on how far it actually was. It seems like the more farther it is for lens 1, the more or less it actually looks like. However, in lens 2, the more closer or farther it is, the more brightness it actually has. And so for our conclusion, we overview all the explorations and why they were done. We did all these explorations in order to attain a better understanding of reflections and images between lenses. The results in which it was an error, we did have a couple of errors, especially when we were doing exploration 4, where we couldn't get an image because the candle was burning a little bit faster than we expected. The reason for this is because the candle burns a lot quicker than we thought, and it just kept on getting shorter, in which you just had to match the length of the candle between the lenses. So we were able to fix it. What we learned was definitely that most things have a reflection, and before you even know it, there's a reason for everything that we do, and in the natural world. We worked fantastic together. Everything that we did was great. We were able to finish all of our exploration, and our favorite part was definitely exploration 1, where we got to see the different views of the different images.